Have you ever wanted to be in two places at the same time? Whoa! Atoms can exist in two states at the same time. That's crazy. I know, right? But it's no magic. It's possible with quantum mechanics. Let's take a closer look. In order to understand the complicated topic of quantum superposition and wave-to-particle relationship, first we must start at the basics.
Quantum mechanics handles the tiniest particles, like protons, electrons, and neutrons.
In quantum mechanics, particles are described as waves. But they're not like light waves. They're a bit more abstract. But remember, particles do not equal waves. It's kind of like water does not equal ice, even though they're both states of H2O. Until recently, scientists were unable to predict when an atom was going to make a quantum jump, or when an atom changes quantum states. Scientists determined if there was a sudden lack of a certain type of photon that would usually be emitted by the atom, that is a warning sign that the atom is about to make a quantum jump. Since we're talking about breakthroughs done by scientists in physics, let's talk about the double slit experiment. In the double slit experiment, scientists would take particles, waves, and electrons and send them through space with a barrier with double slits. Then they would see the interference pattern on the wall behind the barrier.
When scientists send out particles, they observed this interference pattern. And when they send out waves, they noticed this interference pattern. This was because the waves bounced twice, here and here. With electrons, the interference pattern was the same as waves.
And when scientists wanted to see what was going on,
the electrons now behaved like particles.
Decoherence is when we see a subatomic particle. It goes from the quantum state of a wave, it collapses into a particle. In order to understand how something can be two things at the same time, we need Schrödinger's cat. It is a theoretical representation where a cat is put into a closed box with radioactive atoms. These atoms could decay, killing the cat. When an observer opens the box, they could find the cat alive or dead. Hold on, that's what I call animal abuse. That's why we're going to use a plant instead. When we put the plant inside the closed box, we don't know if the plant is alive or dead. So technically, it's alive and dead at the same time. Of course, these experiments are the closest thing we're going to get to actually seeing superposition in action. We can only see the effect it has in the surrounding environment. Quantum mechanics may sound like science fiction, but it's used in many everyday items like computers and cameras. Thanks for watching. I'm Emilia Dobek, and keep exploring science.